Okay, so today we're going to talk about infotainment systems. So that infotainment is a definition is a cross between information systems, where we're going to have a human to driver interface, where may allow you control of certain functions like climate control. It could give you information on how the vehicle is operating, and then also entertain you through music or other functions. And also supports things like navigation. So we see where this human to driver interface concept, and we really saw where Tesla did that on their center console. It's like basically got a huge iPad there. So we're seeing more and more of these things. So instead of having different switches or different knobs for everything, we're combining these into a human to driver interface and call it infotainment. Telemetrics is another term that we use for it, because what are we doing? We're connecting to our cell phone. We're connecting to the infrastructure around us potentially. We're connecting. If I have navigation, or even if I don't have navigation, my vehicle may still be connecting to global positioning satellites so that it knows its location. So this system has come a long way. I remember when I was a kid, my folks always bought cars that didn't even have radios in them. And so they just had the cover over because radios were optional. Now I don't think you could buy a car without some sort of sound system. And today I would say probably many cars have an infotainment system, because we're using that common display for multiple functions. And many times this is a touch screen display. So basic system incorporates radio, CD, MP3, cell phone control through Bluetooth or iPod control, multiple speakers. So, stereos today have come a long way from that old AM radio with a single speaker in the dash. Today's vehicles are equipped with touchscreen LCD displays, DVD players, often separate DVD players or something for each of the two rear passengers. So now the kids don't even need to agree on whether they want to play a game or watch a movie or anything when you're traveling, which gets kind of rid of some of the "are we there yet?" When I was a kid, there was nothing to do in the car. You sat there and waited till you got there. So things have really changed a lot. We have satellite systems, so we're connected. We have the capability of connecting to satellite for entertainment, capability to go online for gaming. So hands-free Bluetooth for your cell phone. So you can see the system is really doing a lot of stuff. And because it's doing so much stuff and because it's so connected, it is a huge vulnerability for the manufacturers. In other words, because it has to be accessible for you to connect your cell phone, or you to be able to get onto satellite or other things, or get onto the 5G network, because that accessibility is created, there is a huge vulnerability that manufacturers are concerned about, because the infotainment system is on a network. And being on a network, it shares information with other modules on the network, which in turn share information with other modules. And at the end of the day, every module is connected to another module conceivably, as the networks are connected together. So if someone is able to hack into a vehicle, theoretically, we could start it and steal it. We could turn it off and keep it from running. We could decide where it goes, again, based on the level of autonomy that vehicle came manufactured with. So if it has a semi-autonomous system like we saw with Tesla or Cadillac, or I didn't show you the Subaru one, I have it up on the canvas, or Mercedes, if those vehicles could be hacked into, since the vehicle has the capability of starting itself, driving itself, steering, applying brakes, managing speed, you can see that car could be hacked into and told to go to a particular destination. And that is certainly the concern of engineers today. So we want to create this great accessibility, while at the same time safeguarding. We can't have these cars as accessible as home computers are. Home computers are hacked all the time. They get viruses, all these things that we see on home computers, and we can't really have that with cars because of the safety involved. We have a vehicle going down the road at 70 miles an hour. We can't afford to have a hiccup. So there's a lot of things going on right now where we're trying to put safeguards in and allow accessibility for the consumer, but still prevent hacking. And I don't know how many of you followed the news on the pipeline on the East Coast that's down from a ransomware attack. And again, these systems are online. Anything can be hacked. It's just a matter of into doing it. So manufacturers are constantly evolving and constantly it alone long enough, it's going to be vulnerable. So the basic system contains a head unit for control of radio CD player along with inputs. Complex systems incorporate satellite entertainment, DVD players for passengers, game consoles, multiple LCD screens, amplifiers, complex speaker systems, and bass drivers. The head unit in the dash is the main control module, common on modern vehicles for the navigation system to be built into the entertainment system. So when we look at networks, which is the next module we're going to be into, we're going to see that some modules are superior to others. Some modules are in control, while other ones are simply passing on information and just controlling their functions, where others are in control of other modules. And increasingly, we're seeing our infotainment system, or our radio specifically as the module, becoming the module in charge for that network, and then that module interfacing to other networks, because the human to driver interface has to get information from the TPMS system, from ABS, from engine control, from all these other things if we want to give you access to that data. Plus, we have systems that the volume of the radio changes as you go down the road. Well, in order to do that, I have to get the information to find out how fast we're going in order for that module to control that. So here we can see an older system where you had a single monitor that can be seen by rear passengers. Now we typically see, just like we do on an airplane, individual monitors on the back of each seat. So we've gone from none to one, and hey, isn't this neat, to now individual, to where each passenger gets their own unique driving experience, very similar to what we see on a modern airplane. So modern vehicles integrate our audio, video, and communication systems into an in-vehicle network. Controls are centralized with the hardware. Communication between components requires a combination of hard wiring and data buses. So just to be clear, a data bus is hardwired. What they're saying here is sometimes we'll have a separate wire that's not a network that allows two modules to communicate with each other or send a specific signal. Like, say, I only want to send you the speed signal from the ABS. Well, maybe I don't put that on the network, but I run a separate wire just from the ABS module to the radio module, says, here's your speed signal. So instead of putting that through the network or having that network, and we see that on older vehicles, newer vehicles, because so many modules are already on a network, it's easier just to use the network. And we will still see on some modern vehicles some of these dedicated signals, but generally they're there for redundancy. They're there so that a vehicle will operate when a network goes down. So for example, we're going to look at the immobilizer, where the immobilizer prevents you from starting the car. I could put that immobilizer signal on the network, and some manufacturers do, or I could have a dedicated wire between my immobilizer module and my powertrain control module that says it's okay to start. That way, even if the network goes down, the car would still start and run, because it can still see that signal that, oh, it's okay to start. So manufacturers will design things differently. So what one manufacturer does is not necessarily what another one does, but these are different options that they use. Databases with data buses, wiring messages can be broadcast over the vehicle's audio system. So instead of worrying about the light coming on the dash to tell you the car is overheating, now the audio system can tell you the car is overheating. The computer may turn off the engine because the car is overheating. So we have a lot more. And if it turns off the engine, what's it going to do? It's going to tell you that the engine's been turned off and pull off to the side of the road. So, these simple messages where we used to tell you that the door is ajar, now we've evolved into different messages based on what system is having an issue or recommended course of action. Audio control functions are usually located in the central control pod on the component's head unit, which is basically the main assembly that's mounted in the dash. So if I look here, I've got my human to driver interface right here, where I'm able to control climate control and other things. And we can see here it's networked, in this case, off with a body control module, and goes into diagnostics, which would be a DLC, a diagnostic link connector in this case. And I can see I have an antenna module. I've got some screens, speakers, microphone input. So this is a very simple system here. There's not very much going on, although it really looks complicated. This right here is our steering wheel controls, and they go through what's called a clock spring, which is a device in the steering wheel that allows you to rotate the steering wheel either way about 2 turns, 2.5 turns, and there's a cable that winds and unwinds that maintains that electrical connection. And so we have some steering wheel controls, and you can tell how old this is. CD stacker. I don't think anything comes with a CD stacker anymore. But you kind of get the idea here of the different things that can be incorporated into. And so each system is unique. That's why if we have a problem, we always want to go to the wiring. What I can tell you is many times when these systems don't work, for example, navigation doesn't work, or even the radio doesn't work, depowering the whole vehicle and allowing the capacitors to discharge and then powering the vehicle back up, basically rebooting the module, fixes probably over half of them. So we've had some very expensive radio units not work, and we isolate it down to, hey, it's got power and ground and it's not working, and we unplug it and let it sit for a while, so the capacitors discharge, plug it back in, and now it's working. So very similar to your home computer. Sometimes it'll lock up and not cooperate, and you remove the power, let it sit a little bit, and then power back up, and now it's working again. So another function provided by body control module is that speed dependent volume, which I talked about. Viewing screens for onboard TV, DVD, or games are located in the dash. If the screen is viewable by the driver, it must be disabled while the vehicle is in motion. So a lot of our controls don't work while the vehicle is in motion. Again, having the need to be tied into vehicle speed. Control modules says here can be hardwired or wireless. What I can tell you is on a vehicle, there are no wireless modules. So I don't know where the book got that from, or if they are reading some spec paper that maybe we'll do this in the future. There are currently no wireless modules on vehicles. Everything is wired. We have a lot of radio frequency interference. We have other issues that can deal with that. Perhaps you could argue that your cell phone is basically a module on a network once you're connected with Bluetooth. But I wouldn't consider that a control module for the vehicle. So diagnosing the infotainment system, like any computer, it's inputs and outputs. So does it have power? Does it have ground? Is it getting the input it should have? And does it give you the output you want? Most manufacturers give you very, very little diagnostic information on the radio. Basically, here it is and nothing else. So they don't really tell you much about it. Problems can range from poor radio reception or failure of the GPS system. So if I back up a little bit to our diagram here, If I can't get any radio stations, but CD stacker works, and it could be a tuner problem, but it could also be what? An antenna problem, right? So I had a Lexus that didn't have good volume out of the radio. And on that car, all the speakers went through an amplifier. In this case, we only have one amplifier we're showing. And there was no diagnostic information other than here's a wiring schematic. Well, an amplifier makes a signal bigger. It amplifies. So sometimes just understanding what something does is enough to diagnose it. So I put a lab scope on the signal coming into the amplifier and looked at how big it was. And I looked at the signal at the same time coming out of the amplifier. And what I found was they were both the same. Means the amplifier was not making the signal bigger, because it should have been like this, right? It should have been much bigger coming out. And it had power and ground going to it. Well, if it has the signal and it has power and ground and it's not making the signal bigger, then it's not amplifying, which is the name of the device. So I put a new one in, and it was a little bit of, I think I'm right. I got to be right. But the part was almost $500. So I really, there was a little bit of concern whether my thought process was correct. Long story short is it fixed the car. But there was no diagnostic information. There was nothing in the factory manual for that other than here's what it is. Here's what, here's what it is. Here's where it's located. And here's the wiring schematic. So a lot of the things that we have to fix on vehicles, we need to have a knowledge of what is it supposed to do? What does the component do? What does the system do? So a lot of it comes back to, like I've said, asking questions. What is this thing supposed to do? If I understand what it's supposed to do, the next question is, how does it do it? And that can be magic pixie dust inside this box, or it can be, hey, it gets the signal from here, and then it makes this happen when it sees the signal. And that's going to really, change that. So that's where diagnosing the infotainment system is, critical. It's really a last question. So always verify the concern, research service information, develop a focused testing plan. So that's your wiring schematic. The other thing that's important is look at the owner's manual. How is it supposed to work? Many times a customer will inadvertently hit a control, either blocking out a function, or they've moved their bass or treble, or they've moved their faders so the front speakers or rear speakers don't work anymore. And they have no idea that that function is in the radio. So sometimes it's just a matter of, hey, if this isn't working, is there a control that the driver had access to make this work? And we're going to find that out in the owner's manual. There's a lot of things that drivers can turn on and off, and many times they don't realize they've done it, because who read their 700-page owner's manual when they got the car? I'm betting no one read it cover to cover. So, I think I'm going to win that bet. So consequently, customers do things to their cars all the time that they don't realize. And when that happens, then something doesn't work. They bring the car into the shop because something's not working. And so many times, especially with infotainment systems, one of our best resources is the owner's manual that the customer is provided when they bought the vehicle. If the owner's manual is not in the glove box because they lost it, left it home, bought it used, for the last 10 to 15 years, most manufacturers have been putting their owner's manuals online on their website, and you can access that for free. So now you're down to searching the manufacturer's website, and so you might just want to search 2015 Honda Civic owner's manual, and you're going to get something pop up, and one of the top hits will be probably a link right to Honda's factory website with that owner's manual. So don't kill yourself looking in a vehicle for something that might not be there. So that's a huge improvement compared to how it used to be. We talked about radio reception issues. Choose stations. Is the problem only on AM, or is it on AM and FM? Those kinds of things. Good power and ground, which requires some disassembly to get to the radio unit. Use a lab scope to detect any unwanted ripple or noise in the power circuit. So back to our diode ripple. If I have excessive ripple in my diodes because I'm getting AC voltage into my DC circuit, that can cause noise, especially on AM radio, a reception issue. Ensure the power connections are clean and tight. Check antenna for corrosion, for resistance. But again, if the radio doesn't work and the CD player doesn't work, it can't be an antenna problem. So this is where really asking questions and understanding, what, just like we did with the lighting system, what works, what doesn't, what are the things that are only used when the system's not working compared to the things that are used when the system is working, to try to figure out what area might be the problem. If the problem is a video device, verify the concern just like any other diagnosis. Once the fault has been located and corrected, make sure you verify the system's operated correctly. So, for example, maybe my screen doesn't put out a good picture. So is it a screen problem? Is it a signal problem? I can check for power. One of the things we did back when we were doing ADOS testing is we actually bought a little $20 Pac-Man game, and we cut the connector that goes to the screen and made it so that we could splice into these different automotive systems. And we would actually, if the backup camera wasn't working, we could unplug the backup camera, plug Pac-Man in. If you saw Pac-Man on the dash, that told you all the wiring and the monitor was working, and it's a camera problem. On the other hand, if you can't see Pac-Man, now what, we need to go to there. I can disconnect the wire, go into the unit and put Pac-Man right there. So something to generate a signal. So that's very out of the box. You're not going to find that in any manual that, gee, go online and buy a video game, and so you can, a cheap video game, so you can put a signal, an analog signal up on a monitor. But those are the kind of things that work. That's how people fix cars, is by, stepping back and going, hey, what does it have to get? And how can I simulate that signal? Or what other signal can I put in? Or can I measure that signal? So those are the kinds of things that we ask as we're diagnosing, because the factory manuals normally say, check power and then check power and ground. And if it's not working, replace with known good unit. Well, that's okay if I'm working at the dealership and I've got a plethora of known good units, and I can just put another one in, and if it works, I fix it. If it doesn't, I can put the old one in and I'll put another new part in and try that. If you're working on customers' cars in the aftermarket, you don't have that luxury. You actually have to diagnose it. You can't just plug in known good parts until the problem's solved. And you kind of laugh, but there's a lot of industries that do that. A lot of computer repairers plug in known good part. A lot of stuff. I don't care if it's for, fixing the washing machine or the refrigerator, or a lot of these things. When it comes to electronics, it's plug in known good part. They're not teaching them how to test it. They got a box of the 5 parts that thing has, and let's plug in our test part, see if it works. So satellite communication and global positioning. So one of the things that we have is a global positioning system. And this was originally developed for military use and used by the military. Many of us are familiar with it now because, it's been around for quite some time, 30 years, plus in the civilian sector. And it uses satellite technology in vehicle systems, providing an ever increasing array of options for the vehicle. Satellite technology is used for navigation, vehicle tracking, theft, recovery, communication, even internet access if you pay for it. Global positioning system is used to determine the exact location of the vehicle on the Earth's surface. And in order to do that, I need to be able to talk to at least 3 satellites. So this isn't going to work real good in underground parking or a long tunnel. We're not going to be able to see the satellites. So this is based on the 3 satellites, and it's based on triangulation. So if I have 3 points, with 3 points, I can figure out exactly where you are. Many navigation systems now are not necessarily using satellites. A lot of them are using cell towers, or they have the ability to use a combination of cell towers and satellites. And as we're moving into 5G, you're seeing more and more of that infrastructure pushed into cell towers for that. And again, it still allows you to triangulate a location. You just need to have overlapping towers, and you need 3 of them to pinpoint a spot. 2 of them get you into an area, but you need 3 to actually pinpoint something. So it can work very accurately. Uh, with this and vehicles, because they know your speed and know your direction, even if you momentarily lose contact, they're still going to have a good idea of where you're at based on speed and direction from the last time they were able to see the satellites. So that's why if I'm going through a tunnel or I'm doing something, many times the process is seamless. It doesn't go to a blank screen and say, we don't know where you are. You still get to see, oh, here I am and here I'm going, because it knows your speed. And it knows, depending on the car, it may know actually also the direction you're taking as far as if you turn, because we have a computer for our steering, so it knows if we turn the wheel. We have a computer that knows how fast the car is going. So once we put you on a map and we can monitor your speed and direction, I don't need to be in contact with you every minute to be able to follow you on a map. Onboard sensors such as vehicle speed, steering wheel can be used to keep track of the location. The GPS relies on a group of at least 24 satellites orbiting the Earth at approximately 12,650 miles. So you need a minimum to hit 3 satellites. You can actually hit more than 3. Each satellite is equipped with an atomic clock on board and regularly transmits a unique radio frequency simultaneously with all the other satellites. And GPS operates on the triangulation principle. So the process is finding a position of an unknown point based on forming triangles with a known. So we're going to take the distance and we're going to, since these are all at the exact same time, they're synchronized with an atomic clock, we are going to send down or transmit this information. And based on the time difference the information is received from the 3 satellites, we know exactly where our position is, because they all started at exactly the same time. So therefore, it'll take different amounts of time to travel. And, keep in mind, these things to the human ear or to us would be basically instantaneous. But the computer is able to see that slight difference in time. So the vehicle's onboard GPS needs 3 things to determine location: the time it took for the signal to travel from each satellite to the vehicle, position of each satellite, and an accurate time. Inaccuracies can be caused by weather conditions because they can interfere with the signal. They can also occur when RF signals are affected, such as large buildings or solar radiation. GPS typically accurate within 25 feet. Many of the systems now are more accurate than that. There was a time when they were not allowed to be more accurate than that because they were concerned about other uses for the technology. Now we see them getting much closer than the 25 feet. Once triangulation has been determined, mapping software stored in the memory can be used to generate an overlay map. So this is the same thing your cell phone's doing, except for today, most cell phones aren't using GPS. They're just using the cell towers. Older phones would give you the choice to flip between cell towers or GPS, but a lot of new ones don't, depend on the model, may not support the GPS system on your cell phone. But so it's just triangulating off of cell towers, but the same principle really applies. If you've ever flown, what's the first thing you do when you get off the phone? You get your phone back on the network so you can get the correct local time. And what does it do? It updates. During normal operation, the computer program compares vehicle position data derived from satellites and onboard sensor information to ensure high levels of accuracy. Ground-based stations are used as an absolute reference point. Cell towers. Satellite navigation features include multiple languages, choice of voice gender, so I'm their voice accent. There's a lot of, again, depending on the car, you have a lot of options. Some cars are, this is what you get. Again, did you pay $25,000 or $125,000 for that car? If you put a 1 in front of the 25, you probably have a lot more options. May also include directional information provided from a combination of screen icons, maps, and audible instructions. So the telemetrics, which is satellite-based system, combines two-way communication and information technology within the vehicle. Allows for vehicle tracking and security features, monitoring onboard systems, messaging, delivery of travel information, entertainment functions. So what industry do you think uses telemetrics the most? Any ideas?
Maybe cell phone.
No, not cell phone. Actually, big trucks, semis, transportation. So they're able to know exactly where their trucks are, how fast their trucks are going. Is that truck exceeding the speed limit? Many trucks now have forward facing cameras so they can see if the driver is tailgating people, if the driver almost hit a pedestrian or any of those kinds of things, did a rolling stop through a stop sign. Also, cameras on the driver to see, is the driver fatigued? Is the driver distracted? And this is all real time data going back to a dispatch center. And so they're able to monitor their drivers. They're also able to change the operating characteristics of a vehicle. So, for example, I'm driving a truck cross country and I'm in a state that the maximum speed is 65 miles an hour. So maybe we're going to set the governor on that truck to 70 or 68. Then I get to a state that has no daytime speed limit. So now maybe I'm going to let that driver do 80. And when they leave that state, I'm going to turn that back down. Or I can watch, is that truck really doing 25 in a school zone? Or is it doing 40? Also allows you to disable a truck, keep it from running, perform diagnostics to a certain level on a truck so that, hey, we see you have a problem here. We're going to make an appointment at this truck stop that you're going to be at in 2 hours. They have the part on hand and they're going to get this taken care of.
Wow.
Pretty amazing, isn't it?
I guess if that's the company, is it legal for them to do all of that type of tracking?
Absolutely. They own the trucks.
Yeah, I guess so, huh?
It's no different than working in a shop and they have cameras in the shop watching me work.
Mm.
That's perfectly legal. I mean, when we did that at the shop, we had some guys that were, a little offended, a little uncomfortable with the cameras at first when we put them in. And then we had a job that one of the guys did, and it went south, and a timing chain hopped on the engine on restart after doing an oil change. All we did was an oil change on it, and the car didn't start after the oil change. And of course, the customers like, well, you guys must have run it without oil. You must have done these other things. Things don't just happen. And my answer to that is, of course they do. That's why there's tow trucks. If things didn't happen, we wouldn't have tow trucks. So let's get rid of that to begin with. But the the thought was, hey, wait, what happened here? So we went back and looked at the video, and we saw that the technician put the oil in the engine, had the filter on, everything before he tried to start the car the first time when it didn't start, and it never started in the bay. So it actually just didn't start on startup after changing the oil. And the video showed, and we showed the video to the customer, showed that we did absolutely nothing wrong. We changed the oil like we were paid to do. On talking to the customer further, because it was a new car or newer car, it had 125,000 miles on it. And we found out this was only her 4th oil change. So she had abused the vehicle, causing excessive wear on the timing chain. So when the car was started up, on the initial startup after an oil change, the timing chain bounced and basically broke. So it was owner abuse is what caused the problem. But if we hadn't had the video, the customer would have never believed us. And after that, there was really no one minded the cameras after that, because it really kind of, got the technician out of trouble and showed he didn't do anything wrong.
Okay.
Satellite help.
So that's the flip side that we never hear about is, we think about, oh, the cameras are there and they're going to show people doing bad things. And yeah, absolutely. Cameras will show people doing bad things because people choose to do that. But there's many times that cameras show that the person who's accused of doing something bad did nothing wrong. And that's the flip side of it.
Mhm. Okay.
So telemetrics are huge for commercial trucking, and it's as a result of this, there's been fewer accidents, less damage to the trucks. Deliveries are more consistent in getting there on time, because now we can see, is the truck moving or is he pulled over at the truck stops for 2 hours when he's supposed to be working, and then just trying to say he was caught in traffic. So they're actually able to really see what's going on and know. And we also benefit from that when we order something online and we can go to tracking. And what does the tracking tells us? It tells us where it's at, between what point it is. Sometimes it even tells you how many stops away from your house it is. So a vehicle manufacturer may offer telemetrics as a service to its customers. So we're seeing this also. OnStar is probably the most famous one. That was GM, but other manufacturers have similar systems. So these systems have the ability to call 911 if you're in an accident. They have the ability to turn a car off if you're running from the police in it, and the police can contact the service provider and have them turn the car off. So much for the high-speed chase. Your car is turned off and the doors are locked, so you'll be waiting there for them. So you can see where this technology really has the ability to change a lot of things. Oh, a car's stolen? Oh, here it is. So there's a lot of things that come into this that people are subscribing to. Another thing it can do is it can come up and go, hey, I can see you're due for your oil change in 300 miles. Would you like me to schedule that for you? And of course, it's going to be scheduling it at the dealer for that manufacturer. But that way, that's all happening. You're going to get asked while you're driving down the road, hey, it's 300 miles away. Do you want us to schedule you an oil change next week or 2 weeks or whatever? Because it knows how many miles a week you're putting on the car. So it's able to look at that and go, hey, let's reach out. Your check engine light's on. We can tell you that it's safe to drive, but let's schedule you an appointment for our service drive, and we'll notify the dealer that you're coming. So you can see where the manufacturers have really jumped on this, because this is a huge service and sales opportunity for them.
Crime solving too.
What's that?
It's used in crime solving too, like they track the vehicles, whether it's near the crime scene or not. I've
Yep.
seen that.
Yeah, they do that, and they do that off the cell phone. They do it off of vehicles. A lot of times they use it for tracking vehicles. When someone says, it wasn't me, I was home all night. Well, your vehicle took a test drive without you then, so we probably need to talk about this a little more. So yeah, they do use it for a lot of crime solving. So here we can see the telemetrics, both the satellite and then also back to infrastructure. And so I talked about vehicle tracking, monitoring onboard systems, messaging, travel information, entertainment, security, safety, fleet management systems, which is huge, roadside assistance. Think about how much easier it would be for AAA to find you if they already have you on GPS and you just go right to it.
They already have that.
Right.
That when I remember I a couple of years ago, my vehicle was giving me trouble, and so I called for a tow, and I was on the phone with them, and I didn't give them access to I didn't give them permission to use it. They just somehow they were telling me where I was.
Yeah.
They knew exactly where I was, intersection and everything. They asked for an address, but they said, "Are you right?" I said, "I don't know the area." And within like 2 or 3 minutes, the lady got back on the phone and told me where I was.
Yeah.
That was creepy.
Yeah. Pretty amazing, isn't it?
Yeah,
So
I said, what's going on? Is my car tracking me or is it my cell phone? I wasn't really sure. I never got to the end of it. I just thought it was weird.
yeah, no, it's amazing. And I don't see Amanda in class this morning because she does AAA service. So I'd love to see where they're doing now. But I know when I've called AAA, they got they got GPS trackers on the truck, so you can see the truck coming towards you. So if for some reason the truck's not finding you, you can say, "Hey, no, you're 1 block away from me, or you made a left instead of a right," and help the truck find. So no, the technology is just amazing, but certainly there's always a combination, just like you said, as we embrace more of this technology, we lose some privacy. It's a trade-off. You don't get all the privacy and all the technology. So everything we do, there's a trade-off there, isn't there?
Yes. Is that like it now? Is that the same thing as what they're talking like the black box or something?
Well, no, the black box would be our ABS module, and that only records information in the event of an airbag deployment.
Okay.
That's the only time that we're going to hit the black box. Good question. So the system can include location and immobilization of a stolen or lost vehicle, notification to emergency vehicles after an airbag deployment, engine shutdown, door unlocking in the event of a severe accident. It can also be, you can contact and say, "Hey, I locked myself out of my car. Can you unlock my car for me?" So it has the ability to do that also. Roadside assistance, even some remote diagnostics for some faults. In other words, is it safe for me to drive the car to a service facility? Our anti-theft systems, which are also built in, have things such as a theft deterrent systems, theft deterrent door locks, remote keyless entry, remote start, starter or fuel disabled. And so cars have come a long way. We went from just locking the doors to having power locks so I could lock all the doors. And then we came up with alarms to let everyone in the neighborhood know your car's being stolen or your alarm's broken and just goes off all the time. To integrating where we don't let you start the car without the right key, which we've talked about, the transponder keys. And then we also have where we're going to use GPS now to go find your car that's been stolen. And LoJack was a company that came out with this years ago. So anti-theft systems is not just one system, it's a combination of all these different systems. And again, depending on the system that's having a problem is going to determine what kind of diagnosis I'm going to use. In the old days, a Slim Jim like we see here was good enough to get into most cars very quickly. So manufacturers started putting a plate above where the lock mechanism is it used to get to the Slim Jim with, so you couldn't do that anymore, right? So then had to change how you got into cars. So things constantly are evolving. And theft deterrent systems aim to prevent the vehicle being entered, started, or driven. Actuators are used to achieve this, such as electric door locks and windows, starter motor relay, engine management systems, transmission shifts on lights. Hey, you can start the car, but you can't go anywhere because you're still in park. An audible alarm. Theft deterrent systems can be divided into 4 categories: component identification, vehicle locking, engine and transmission immobilization, meaning that they're not going to start or move, and audible and visible alarms. So you do have cars that might have an alarm with no immobilization. So, and I've seen those cars, they're driving down the road with the alarm going off because the car has the alarm, but no immobilizer. There's other cars that have an immobilizer. You can't start them, but there's no alarm. Most cars built today have both an alarm and a immobilizer built in from the factory. But yet car dealers are still putting alarms on brand new cars and trying to sell them to you for $300 when you're buying your new car. Which is just redundant because you already have an alarm on the car. It's how it's built normally. And the one that they want to sell you is not nearly as good as the one that it came with. And I've made a lot of money over the years taking factory alarms off, because after about 8 to 10 years, they stop working and cause the car not to run if it has an immobilizer built in. Then the car gets towed in. I got to figure out why it doesn't run. I figure out it's the alarm. And then I got to pull this alarm out of this car. And so, there's a couple $100 of labor between diagnosing what's wrong and pulling the alarm out to make the car run and be reliable again. And, all that could be avoided by not buying something you don't need in the first place.
Is that the engine kill switch that they put on the cars? Is that what they refer to it as?
Yeah, I mean, in the old days, they used to put an engine kill switch in. I mean, occasionally I still see people do that. But again, the computer's already doing that on most new cars because it has a transponder in the key. So the engine's already killed. We already have this factory technology that's very high tech. So why are we spending money to put a hidden switch somewhere? But people do things that we did, not realizing how the technology has changed. And of course, most people buying a car at the dealership don't know what the new car comes with. So they're just, I want my new investment of $20,000, $30,000, whatever it is, to be protected, because this is I'm going to be paying on this forever. I want to make sure it's protected. So at that point, they buy the alarm because that $300 or $400 is another, $2 a month on the payment or something. I mean, it's just nothing. And that's how those dealers sell this stuff.
Mm.
Some manufacturers etch the VIN number into labels that are attached to various components. So one of the common things is all the glass on the car. So you can go out and look at your windows, and perhaps your VIN number or part of your VIN number will be in each of the glass. Microdots are small plastic particles that have been entered the VIN and unique imprinted on them. Can be seen by using ultraviolet light and a magnifying glass mixed with an adhesive and sprayed onto the underside of the vehicle, into wheel wells, engine bay. So sometimes we have labels that are big enough or engraving big enough we can read the VIN. Other times they're using this microdot technology to put that information there. But what used to happen is if someone stole a car, they weren't selling the whole car. They were parting it out. You probably heard the term chop shop, where they're chopping up a car to sell the pieces because it's worth more as pieces. And in the old days, the only thing that had numbers on them were engines and the frame or body. And then they stopped recording numbers on the engine. So all you had is the vehicle identification number, or VIN. And that was only mounted in 3 places on the car. So by the time you cut those out or threw away those parts, there was no way to prove that this steering wheel or this window or this fender came from a stolen car. So even if law enforcement went into a place selling used parts and they knew in their gut those parts were stolen, they couldn't prove it. And that's what brought about the microdotting was, and putting VIN numbers on all these components is so therefore the thought was, if you got rid of the market for these parts, people wouldn't be stealing them, wouldn't be stealing the cars to sell the parts to the people that were in turn selling them, by making the parts lose value by putting these numbers on them, because these numbers can all be traced. So vehicle locking, a security system automatically locks the doors once the vehicle has reached a preset speed. Deadlocking adds further level of security. In a keyless system, remote control keys and key fobs transmit a coded signal that is received by the vehicle's anti-theft module. And if a code meets the preset criteria, the module enables either the driver's door or all the doors to be unlocked as required. High frequency electromagnetic fields are used to exchange information. So we're sending information back and forth between our key and our car, telling it you're authorized to open it up. You're authorized to, and it's been set to where we only want to unlock the driver's door, or we want to unlock all the doors. Many systems, you hit the unlock button once, it unlocks the driver's door. If you hit it a second time, it unlocks the rest of the doors. On some vehicles, when the key is beyond a certain range from that vehicle, the theft deterrent module locks the vehicle automatically. Hey, you forgot to lock me and we want to be safe. And that is why when I'm working on a vehicle, the first thing I do is roll down the driver's window, because I have been locked out of cars before, and there's not much worse. And they'll do this sometimes, even sitting there running in the service bay. So now I have a car that's locked, running, sitting in my service bay. So the first thing most technicians will do, and the first thing I teach people to do, is put down the driver's window when you get into a car. If the driver's window is broken, put down the passenger's window. Get a window down so you have some way of getting into the vehicle should the vehicle lock itself when you don't want it to. And this happens all the time. Vehicles lock themselves when you don't want them to lock all the time. And if the windows are up and the keys are in, now you've just created a new problem that you need to take care of because you created the problem. It's not something you're going to charge the customer for, and you really don't want to call the customer. Do you have another set of keys you could bring down? Oh, I can't get there till about 4:30 this afternoon, or I can't, I'm at work now. I can bring them by tomorrow morning. Well, what are you going to do with this car that's sitting in your stall where you're supposed to be working that's locked up? So that's why you'll see a lot of times technicians, or when you get the car back, the driver's windows down. That's just good practice, is to put that window down so that you have access to the vehicle, and you're not going to get locked out of it. Some systems can be personalized so that they do or don't lock at a certain speed. So I can hit one button and all the doors always unlock. So the car locks itself out after 20 seconds, or it doesn't lock itself. So there's a lot of presets that the customer can do. Again, the owner's manual is going to explain how those work, not the service manual. And we talked about immobilization already. And this occurs when a theft deterrent system prevents the vehicle's engine from starting or transmission from operating. So this is basically a high-tech kill switch. So unlike just having a switch that keeps it from cranking over, this is going to actually prevent it from starting. So we're going to shut off fuel. We're going to disable the starter. Some systems keep the transmission from being able to be shifted. This car is not going anywhere. Audible and visible alarms may be activated. Operational characteristics vary greatly among manufacturers. Systems use a code system known as rolling codes, and the coded data is transmitted and received between the key fob and the theft deterrent computer model, randomly changed. And Mercedes uses 256,000 rolling codes, and each key has its own code, and the computer knows which key, what key number it is. Computers normally know, so your keys are not the same. They each have a unique signature, and when they're programmed into the anti-theft module, it knows this is key 1, this is key 2, this is key 3, and so on. And so each of those keys gets a different code on some systems. Many manufacturers just use a static code where, this is key number 3, and he's going to tell me his key 3, and I'm going to let him in. Other more expensive cars like Mercedes actually use a rolling code where each key gets its own new code each time. So that's why some keys can be cloned. Hey, we're just going to make another key 3, and it just thinks we're both key 3, and it's all good. But on a car with rolling codes, that won't work, because one key 3 got the new code. The other key 3 has the wrong code now. So when it's tried to be used, it won't work.
Mr. Brian, in your experience, how often do you see like the problems with these systems, and what are those problems?
It's fairly little, when you look at the scheme of things. I probably see alarm problems or mobilization problems in the shop. I'd see them a couple times a month. So it's not never, but you figure if we're seeing 600 cars a month and I get, 2 or 3 of them with alarm or immobilizer problems, it's a pretty small percentage.
So it's not, like a problem most of the time. So you can rely really on these systems.
Yeah, no, the systems are very reliable, but you figure how many cars are out there. And of the ones that we see with alarm problems, the majority of them are aftermarket alarms. The next most common thing is it's a bad key. And I actually had a student with a BMW when we were on campus, and she came to me and says, my car won't start to go home. And she told me what it's doing. And I said, well, it wouldn't crank over. And even though the battery seemed charged up, I said, well, it sounds like a key problem. Do you have another key? And then talking to her a little bit, I found out that she grabbed a key that she normally doesn't use. And her husband has the key they normally use. And I said, well, before we go down the rabbit hole on this, let's have your husband bring the other key. And he brought the other key, car started just fine. And BMW is unique in that they have, instead of a replaceable battery, like my little key here has a battery you replace in it, BMW has a battery in the key that is charged when the key is in the ignition. So if you don't use a BMW key for an extended period of time, the battery goes dead. So you actually have to use the keys very frequently to keep the battery up on it, but they use a rechargeable battery. And that's what happened with hers. Her key that she didn't use all the time, the battery was weak in it. And so it had enough to start the car in the morning, apparently, but not enough to get home from school. But that's an example where even though we're at school, even though we have the shop, even we could have pushed it up or I could have grabbed a lot of tools, wait a minute. We know the system has an immobilizer. The first thing we do, if I think I have an immobilizer problem or may have an immobilizer problem, is I need all the keys. And if one of the other keys starts the car, guess what? You've just diagnosed the car. So between keys and aftermarket alarms being broken, that's probably 80-90% of the problems right there. Occasionally I've had bad antennas or bad modules or things like that. But that's the exception and not the rule. Most of it's either an aftermarket alarm or a key problem.
So when a car is brought in a shop, how would you know that the car has an immobilizer? You ask the customer, or you look at the
No,
key?
customer usually doesn't know.
Yeah, I wouldn't know that.
Right. So some of it is looking at the key. Okay. This key is pretty big. It has buttons. So odds are this car has an immobilizer. If I am looking, I don't have my other key here. If I am looking at just a regular metal key, it probably doesn't have an immobilizer. So again, it kind of comes from asking questions. So if I see a fancy key, I kind of think, okay, we probably have an immobilizer here. I can also do some research. So I might go to AllData or Mitchell, for service information and see and search immobilizer, or go to theft deterrent systems and see if that vehicle uses an immobilizer. I might use a scan tool to talk to the vehicle network and see if there's an immobilizer or a theft deterrent module that reports on the network. I might look in the owner's manual to see if the owner's manual talks about keys at all or anything special. So, it all starts with a question. I think we should always, on a modern vehicle, we should always ask the question or assume it probably does have one. Certainly anything made the last 10, 11 years, I would expect it to have one. If it's newer than 2000, it's probably 50-50, maybe even 75-25 that it's going to have one. If I'm working on a 1990, odds are it doesn't. There was only a couple manufacturers that did then, and they were very high-end cars. So it's something that's evolved over time. But a late 90s, early 2000s Ford has an immobilizer in it. So we have seen this, going back now for 20 years. So at this point, I think I would assume a car does, and be really surprised if it didn't.
So if a car is not starting, we don't assume right away that there is like an engine or starter problem. We can start with the key, the immobilizer, if there's a problem. That's a good start.
Yeah, it's certainly a question to ask. So if I think I have a battery problem, do the headlights work? Right. So if I turn on the headlights and the headlights don't come on, okay, that may be a clue. But on the other hand, Some cars, the headlights won't come on unless you turn the key on the ignition on, right? So that's not an absolute, but hey, does the dome light come on? Does the dome light get really dim when I try to start the car or go out? So we can do some kind of preliminary checks to kind of try to figure out, do I have a low voltage problem or do I have a key problem? So it's, sometimes we have a warning light on the dash. It'll be a picture of a key flashing or something like that, letting us know that the immobilizer is engaged. Sometimes we'll get a code in a module so I can scan the powertrain control module. It'll tell me, I've been told not to start because the immobilizer told me. So sometimes we get different clues. Each car is a little different. So we really kind of need to, ask the question. We need to look at the dash, and then depending on what tools are available to us, we can go deeper. But again, if I turn the key on and turn the lights on, do the lights light up or the lights still out? Well, if the lights are still out, now I'm really thinking I have a dead battery.
Okay, thank you, sir.
You bet. So now, as far as alarms go, we have factory alarms. From a factory standpoint, alarm is just an audible noise. Anything that keeps the car from moving is an immobilizer. On aftermarket alarms, there are alarm companies that make stuff that will keep you from being able to crank over the starter or may disable the fuel pump. So the alarm, even though it's called an alarm, has an immobilizer built into it also. So depending on the sophistication of the alarm, it may just make noise, or it may make noise and not let you start the car. It can have glass sensors. It can have all kinds of stuff. So so aftermarket alarms are not nearly as common as they used to be. There's some good aftermarket alarms and there's some horrible aftermarket alarms, just like anything you buy. But again, newer vehicles really don't need this. They have a factory alarm built in. Almost all new vehicles have a factory alarm. So before you think about putting an alarm on your car, check you probably already have one. Or if it has a good immobilizer, do you really need the alarm? Do you really need it to be making noise at night when someone's breaking into it, because they're not going to take the car? And are you going to hear the alarm if it does go off? It kind of depends. Or do you park your car in the garage where it's a non-issue? And we've all been at the supermarket or the mall or a big store with a big parking lot, and there's an alarm going off. Does anyone really pay attention to it? Does anyone really go look and see what's happening?
Not anymore.
No, it's just someone's stupid alarm is going off. Ignore it, is what we say to ourselves.
It's digitized.
Yeah, exactly. So is it really worth my investment if my car doesn't have an alarm to put one on? Well, it depends on where I park it, where I leave it, what I do. Am I going to be able to hear it from where it's parked? I can't really depend on someone else doing something with it. But that's, on the alarm. Many aftermarket alarms, as a rule, are not repairable unless it's a connection issue going to the alarm, like a wire came loose or something. So they're really one-time use. And if they have a problem, you pull them out, throw them away, and put a new one in if you want. And normally by the time we pull them out, I've never had a customer want another one installed.
Now, I have a question.
Mm-hmm.
With all this technology nowadays, how is it? I mean, who's stealing cars and stuff like that? I mean, it seems to me that it's almost impossible unless you know this, you know what I mean, know this stuff. So,
Right. So it is almost impossible to steal a car without a key today. So consequently, a lot of cars that are stolen are what? Older cars, 90s vintage cars. A lot of older stuff is stolen. If I just want to joyride, I'm going to steal something that I have the technology to steal. Then you have the other extreme where there is devices out there that clone keys and do other things where I can steal some high-end cars by cloning your key or stealing your key information. And that's where the professional side is. So you have, a very, very high-tech professional side, and you have the I want to go joyriding side. But what you're seeing is fewer cars are being stolen because of what we've done with parts and because of what we've done with technology. we now are stealing parts off of cars while they're there, such as catalytic converters.
Oh yeah,
So
yeah.
they just busted a group up in LA a couple months ago, and they had $750,000 worth of catalytic converters in the warehouse that they'd been stealing from people.
Yeah,
They hadn't made to the recyclable yet and got, I mean, they were doing so many of them, they hadn't even been able to get these turned in for money yet.
yeah, I saw something a couple of weeks ago on that. That some of the places now are offering to like spray paint your catalytic converter and then etch the your license
Right.
on it on the catalytic converter after they spray paint it.
Right. Well, the paint's probably not going to stay there very long because they get very hot. But yeah, no, there is. They make cat guards. They make all kinds of stuff because catalytic converter theft is big. And think about it. You know, if I'm stealing a catalytic converter off a car, and say it's an expensive catalytic converter and it's worth a couple $100, that's a misdemeanor. I steal the whole car. That's grand theft auto. That's a felony. So even though combined it makes up for a lot of money, and certainly the people running the stuff because of the dollars involved, are potentially facing prison time. The people that are actually cutting them off the car, it's pretty low risk because each thing you're doing, you're not stealing that much money, and because of where the limits are and all those things, especially in California. I mean, that's one of the things that's encouraging. Wait a minute. So I can go steal stuff, and if I get caught, I'll be home the next day and I don't get held and I'm not going to jail. I mean, where's the deterrent from doing it?
Wow. So how is it that they can even use them? Because I thought, I mean, somewhat was telling me that they can't, they even if they take them, they can't use them on another vehicle because of the DMV, like if they go to try to get it smogged or something like that. Is
Right. So they're
that
not using them on other vehicle. What they're doing is they're melting them down for the precious metals. They have platinum, palladium, and rhodium inside them that are very expensive, especially rhodium. And the rhodium is like $100,000 a pound or something, just ridiculous like that. It's extremely expensive. So, that's where the value is the precious metals. So what they do is they sell them to a recycler, which I've done for years. And then the recycler pays you for the catalytic converters, and they sell them to someone else who in turn melts them down and gets those precious metals back out of them.
wow? Who would have thought? Okay, that's I was wondering why would they take them if okay, so they're taking the stuff out of it.
Exactly. So, when we look at the value of that.
Well, they should do it like they do the metals, like copper and stuff. People steal this copper out of people's houses and, vacant properties, and they should make it where these people can't take that stuff in. Like,
Right.
you know what I'm talking about?
Yeah, exactly. And there's been some talk about that on catalytic converters, but yet as a shop, it's legal for us to take in catalytic converters. I mean, we're required to actually recycle them. I can't throw them in the trash. But to give you, gold is what? Somewhere $1,900 an ounce, something like that right now, $2,000 an ounce, somewhere in that range. Rhodium currently is $28,000 an ounce.
Wow.
So 1 kilo of rhodium is over $900,000 at the current price.
Wow.
So
But
you can see why they're stealing those things. That's expensive.
well, I mean, I never even heard of this. My question is, who's buying this stuff, and what do they use that for?
Well, a lot of it gets recycled back into catalytic converters.
Oh.
Or other things. Again, it's a precious metal. But you compare rhodium at $28,000 an
For
ounce.
jewelries.
What's that?
Or jewelries.
I don't believe rhodium is used for jewelry. Platinum is, but platinum is only $1,200 an ounce.
Mm.
So, I mean, rhodium's extremely expensive. Um,
It's really what is it, a really precious metal or a
really
really
precious metal. I mean, way more expensive than gold. So I don't know all the uses for rhodium. I know what we use it for in catalytic converters. I don't know all of its uses, but it's extremely expensive. So that's why they steal the catalytic converters. It's twofold. One, cards have gotten a lot harder to steal. So both from a stealing standpoint, and we're putting the VIN number on so many of these parts. So even if I steal the whole car, how do I get rid of it? And then you compare that with the risk, right? You know, Grand Theft Auto, I can, you know, go to the Gray Bar Hotel for several years. But yet stealing a catalytic converter, I don't have the same risk, but yet I'm using a cordless Sawzall, and how many catalytic converters can I steal in a night? And if I'm getting $50 a piece or $80 a piece for them, and I'm cutting them off, and I get 10 a night, 20 a night. You could see that's a lot of money involved. You see why people are doing this.
yeah, messing up people's cars too,
Oh, absolutely they are.
Car.
Absolutely. And all of our insurance rates go up and everything else. Absolutely. I'm not condoning it. I'm just saying I understand
No,
why
I know,
people do it.
I know. I'm just thinking that, the whole fact that they do this is just to mess up people's cars for a little bit of nothing.
Yep. Absolutely.
Sir Brian, it's used for jewelry, for plating jewelry to make it stronger.
Oh, okay.
I didn't know that it's a byproduct of platinum, in mining platinum. That's why it's rare and more expensive than the other metals.
Ah. Yeah, I know it's really expensive.
Yeah.
I don't think I'll be buying a rhodium ring anytime soon, right?
Yeah.
Solid rhodium. Everyone's gonna look at you like, what's that? Really expensive. So I'm going to stop the stream. So what do you guys think of our telemetrics and infotainment? Learn some stuff?
Makes us spoiled in using our car.
Yeah.
Well, if you want the convenience, I mean, it's a little scary and undaunting. While I like the technology, it's just the flip side of it. What you have to give up. You have to really think about, it's crazy.
Yeah, no, absolutely. And we always have that trade-off.
It's not that you're doing anything wrong. It's just like, wow, I don't know. It's kind of scary. Like Big Brother.
Yeah, no, absolutely.
Your car or whatever is not so much invading your privacy because you choose, but who knows that all this stuff is in cars. They don't tell you this when you go buy a car. They don't tell you all of that.
No.
They show you the glittery side of it. Like, oh, this will your car do this, that, and the other. And you really have to think about it. Well, if it's able to do all of these things, what aren't you telling me?
Right. And that's no different than our home computers we buy, or a Ring doorbell, or a baby monitor, or a smart fridge that tells us what food we need to get as it's looking in the fridge to see what food we have.
Yeah.
So, I mean, do we get to a crazy world where the food police say that I don't have enough vegetables in my fridge and I have too many sweets and too many carbs and I'm not allowed to buy these because I'm over my limit? And, I mean, where do we go, right?
It sounds great. But some people, I mean, they could get to that. Look at how things were in few years ago in New York, with the soda and stuff. What was that? Bloomberg, Michael Bloomberg?
Yep.
You couldn't, I mean, while it's a good idea and stuff, and, to be health conscious, what if, people may not want to do that, and
Right.
who has a right to, I hear I get it, but
Yeah, what? I'm in trouble because my ice cream to vegetable ratio in my freezer is not correct. I mean, you know,
you have a lot of people going that way that want to infringe on other people's right and tell everybody what's best for them or what they should do. Well,
Mhm.
again, it's a good idea that people do this, but do you have to be forced to do it? And
Right,
just like them know, maybe no, you may not need to, but if you whatever, if you accidentally go over a speed limit or whatever, they're going to charge you extra on your insurance, all these different things.
right. Yeah, so why do we need
Car spying.
motorcycle cops if I can tell when you go too fast and your car's connected? I can just print your ticket out on the dash or just give you your ticket on your display, right? We don't even need to do that.
It's like your car is spying on you, basically.
Yeah. The technology's there. And you could also argue if it's about safety, we were talking yesterday that 30 to 35,000 people die in cars accidents every year. How come your car is allowed to go more than 25 miles an hour in a school zone?
Right.
How come your car is allowed to go more than 25 miles an hour on a city street where the limit is 25 in a downtown city? Or why is it allowed to do more than 70 on the freeway? We have the technology, and I've already shown it to you with the vehicle, levels of vehicle autonomy that we currently have,
Right.
and with the navigation we currently have,
To
that
slow
we can
down.
limit vehicle speed based on posted speed limits on most roads in this country. We already know what they are. We have it mapped.
Not only that,
So,
think
right?
about the people. Yep. Not only that, think about the car chases and stuff.
Hmm.
The technology, I know they have it where they can slow these cars and stuff down. That should maybe be something that's mandated that it built into cars as a safety feature so that people don't get run down in these police car chases. I
Right.
mean, to me, that makes more sense than some of the other stuff. But yeah, like you said, or even people driving in residential school zones, you know, with the navigation systems that are out there and the stuff you just showed, it should be that they could just slow it down. If people don't
Absolutely.
sense.
And that's using existing technology and it would save lives. I think you get a lot of pushback from the consumer because even though I'm only allowed to go 75 miles an hour, I want to buy a car that'll do 150 or 130, right?
Well, what
Reality
purpose
is
unless you're
there's
putting
nowhere
out
you can legally drive it that fast, but yet we buy cars that go that fast.
right? That's a question I always ask too. And why don't unless you're putting it, unless you're a race car driver or you're taking it to the track, it shouldn't be that you can. If legally you can't drive over a certain speed limit, why even have it? Why even allow it?
Exactly. And that would be easy enough to engineer into every car starting tomorrow because every car today is the computer controls the throttle and the computer knows how fast the car is going. So my question is, if it's about saving lives, if we care about lives so much, and that's our primary concern, and we care about emissions because the faster you go, the more emissions you put out, the worse fuel economy. Why are cars allowed to go faster than 75 miles an hour or 80 miles an hour, whatever that
Speed limit.
magic number is?
Let me ask you, why is that?
Because it's clearly not about saving lives. It's clearly not about saving the environment. It's about whatever we want to push. Because, I mean, we got what? A lot of people die. I mean, for something that would cost manufacturers $0 basically on a per unit basis to tell them, because we already limit speed. I mean, my wife's car is limited to 126 miles an hour. We took it out to a lake bed and played with it. Manufacturers already limit speed now. Why are we limited at 126 and not 76 or 80 or and why aren't we regulating that? I mean, if it's about making things safer, I mean, so now high speed chases wouldn't be able to go over 70 or 75
Right,
or 80 or whatever that
right,
is.
right. And then you wouldn't even have to, I mean, you could eliminate, I mean, you technically could, I mean, we're sitting here talking about this technically, if they have the capabilities of slowing, even if they could slow it down to speed in pedestrian areas or school zones, they could really, if you think about it, they can map out this whole thing uh, for whatever speed limit you're in. Now, of course, it can't probably help you if you're just stuck on stupid and decide to go the maximum speed limit and the conditions don't cause for it. But as far as you being in a certain, like, speed limits change 25 to 30, 30 to 35, 45, 55. When, with the tracking, it seems they have in the transportation system, it would seem like they could harness those vehicles whereby they can only go as fast as the speed limit allows in that neighborhood area,
Yep.
whatever. You know what I'm saying? So
I know exactly
you
what
could
you're saying.
eliminate. You should be able to eliminate this this whole thing with it would cut down on a whole lot. That's what it just seems like.
It would cut down on injuries, it would cut down on deaths, it would lower emissions, it would increase fuel economy. There's a lot of things that go in. And I mean, the technology is cheap. I got a backup camera for my 95 Cherokee. It comes with the camera, actually, and then it comes with the rear view mirror replacement that has the full display and a forward facing camera, and it's GPS connected and all this other stuff. And it was like $130 retail or $120 retail. I mean, it's cheap. And I'm going down the road. It puts up a speed marker sign on the display telling me what the speed limit is for the street I'm on. And this is $120 bought on Amazon, put on thing. And the technology's in that, connecting to GPS and knowing what the speed limit is for the road I'm on. So the cost to a vehicle manufacturer is minimal. Like I said, basically free on a per vehicle basis. So you can see where
Well, who
that
fights
really
who fights and advocates for these things?
What's that?
Who fights and advocates for these things, these ideas to
Well, you would
come to
think
fruition?
that, there's a lot of different groups that talk about vehicle safety. I mean, there's a lot of stuff. You'd think, you think that some of the people in Congress or some of the other stuff would have brought these up. I mean, this isn't exactly something we just invented this morning.
Question.
Yes.
Oh, we learned all the three satellite works on the one car theft, but also the hacking of the gas pipeline from Virginia to Louisiana just going on, hacking what the satellite is doing for hacking the gas. All the gas stations are stopped.
Well, I don't think the satellite's necessarily doing anything with it.
No, for the car theft, it is we just learned, and all the gas pipeline they dry. There should be some solution for the hacking the gas.
Well, there is a solution. It's a matter of having, good infrastructure on your computer network and have a good backup plan. And most of our industries, including our grid, don't do that, which leaves them susceptible to hacking. So, I mean, I mean, the same thing could have happened to the electrical grid or anything else. And they're still figuring out what happened. And we're certainly not getting the whole story at this point. I've had ransomware attacks. We had one on my work computer, and I was like, no big deal. We're not paying anything. We got stuff backed up. We're just going to dump it, reformat the drive, and we were back, that afternoon working just fine. But we had a backup plan. So apparently their backup plan is lacking. So not only did they not do a good job of security, but they don't seem to have a good backup plan.
It is a part of the auto industry from Virginia to
Well,
Louisiana.
no, it's not part of the auto industry. It is part of the, fuel transportation industry.
Yeah, fuel transportation and connected to auto.
Well, only because we use gas, but
Right.
yeah. But no, but like I said, and again, it comes back to how computerized do we need a pipeline? When they built the Alaska pipeline in a much worse environment, It wasn't all computerized, but yet you don't hear about it breaking down.
Or
Okay.
perhaps maybe we need to go off grid with some of this stuff.
Yeah, not everything needs to be accessible from your cell phone on your day off.
Right. But still, blaming Russia attack or anything easy, but the specific satellite give the exact location with the immobility, the information, all are possible by satellite.
Yeah, absolutely. But again, like we were talking, the more conveniences we get, the less privacy we have, and the more vulnerable we are. So that's the trade-off, isn't it? And there's always, people willing to take advantage of that.
Yeah.
So good discussion on technology. It gives you guys some things to think about, because we see stuff on the news all the time about, oh, we need to do this to save lives, we need to do this to save lives, and yet we have this auto technology that we don't seem to want to use that would save lives. And it's a fair question to ask why we don't do it. So networks, we did introduce a little bit of networks at the end of 55 when we talk about lighting systems. So in this chapter, I really get more in, and there's 2 PowerPoints here, and these are up on Canvas. There's 2 PowerPoints here. One is from the book, chapter 56, and the other one is one I created, which is the one I'm using, which really talks about really kind of what we're doing, and really kind of breaks it down to what a network is and how it works. And we'll look at some different network protocols. So we have 2 different parts of a network. One is the physical connected wires, and the other is the programming language and rules that are used. So I can have a 1-wire network, or I can have a 2-wire network. And on that 1-wire network, I can have a lot of different rules for how those signals are controlled. Same thing with a 2-wire network. I can have a lot of different rules. And some of those rules are standardized under CAN. So there is a Bosch CAN article that there's a homework assignment on in this module. And Bosch, I think first of all, Bosch invented CAN, which stands for Controller Area Network. And the article they wrote, I think, is good and not too long, and has pictures and pretty easy to follow. So I like it. And really kind of explains the CAN protocol and the logic of CAN pretty well, and how we do it. Now, with anything, because CAN is open architecture, very similar to Android, if we held up 10 different Android phones, there's going to be some similarities, but there's going to be a lot of differences also. Same thing's true with CAN. So we have some consistencies between manufacturers. We have some inconsistencies also occasionally. So for many years, as vehicle manufacturers added new features to their vehicles, they had to add more sensors, actuators, wiring to accommodate these new features. And these additions added more complexity to the vehicle and required a larger, more expensive central computer. So what the auto manufacturers did, instead of having one central computer, is we're going to divide these computing resources up among multiple computers, because not every car has every system. And so that way, as we add options to a car, we can add computers as needed. So what we see on a lot of newer vehicles is there'll be one wiring harness, and based on how it's built, different things are plugged in, because it's cheaper to make 1 million of the same thing than it is 200,000 of these, 300,000 of these, 400,000 of these, and so on. It's easier just to make 1 million of the same thing and then plug in what's new. So it's not uncommon today to look at a wiring harness and see a connector that might not be used. So for example, before electric cooling fans were first controlled by the powertrain control module, it was not uncommon for an engine to have 3 coolant temperature sensors or switches. One for the coolant temperature input to the PCM, or the engine control module, ECM. One for the electric cooling fan operation, so controlling a relay or controlling the fan directly, and one for the coolant temperature gauge or warning light on the dash. So now I had not only 3 sensors, but I had wiring going to 3 things. So As I increase the number of connections, I increase the chances for corrosion, bad connections, broken wires, as well as I'm adding weight to the vehicle. So these extra sensor switches were redundant, added weight. Remember, everything's about fuel economy because fuel economy equals emissions. So the better my fuel economy, the fewer emissions I'm putting in the atmosphere. So it also had more potential for system failure. To eliminate these problems, manufacturers changed to a network system. So we saw this happening in the 80s. We saw some networking happen. First CAN system was 92, Mercedes. So networking has been around for a while, since the 80s. Some manufacturers were quicker to adapt it than others, or not allow us access it. These early networks were very small, sometimes just an engine and a transmission talking back and forth to each other. Then we added ABS, so now engine, transmission, ABS. And then, now we have airbags, so engine, transmission, airbags, ABS. And we go into the 90s, that's really what we saw. And then all of a sudden, the late 90s, we saw an explosion of computer technology. And with these networks started getting exponentially bigger, and we started having multiple networks on a vehicle. And that's where we are today, 20 some years later. So a network system can use a single sensor for many modules that need the same information. Is that true or false?
True now.
True.
True, absolutely. And as always, I will open a quiz up when we get done with the PowerPoint that'll have all these questions in. So here's an example of some of the modules that I may have on a vehicle. And so you can see I have driver alertness or night vision, adaptive front lighting, electronic timing control, electric power steering, blind spot detection, tire pressure monitoring, analog brake. I have all these, and not one vehicle, some of these are mutually exclusive systems, but this is really just designed to give you an idea of how many different systems are out there. And like I said, some cars have over 160 modules. So we're talking just a lot of systems. So I don't want to put all of these on one network, because if the network got shorted, everything would shut down, nothing would work. So I need to divide this into smaller networks, and I'm going to put modules that are similar together in the same network. So similar can be by function. More commonly, similar is based on the speed and computing resources required of the network. So the higher speed the network is, the more data it can handle, the more data it can move back and forth, but at the same token, the less reliable it is. And it's exponentially more expensive to make. And manufacturers don't want to make anything more expensive than it has to be. So we're going to use inexpensive, slower networks for some systems and more expensive, very fast networks for other systems based on what the modules in that network need. So it's not just about how close they are to each other. It's not just about, gee, they have a similar sounding name or they kind of do the same thing. It's really based on, do they have similar requirements of communication? And that tends to be how we bunch our modules. So a local area network, the advantage of having a local area network system is our eliminates hardwiring of sensors and actuators to every component, such as the PCM, warning lights, fans, etc., which result, believe it or not, in lower production costs. Eliminates redundant components and wiring, which reduces weight, better fuel economy, lower emissions. Reduces potential system failures because there's fewer opportunities to have an open circuit or a short circuit, etc. There is also less wiring and connections. And information transfer is faster between component systems. So now we're able to get the information of how fast the vehicle is going to my engine computer and to my stereo at the same time. So it's a faster transfer. Which of the following is an advantage of having network systems on the vehicle?
All of the above.
All the above. Less vehicle weight, better vehicle reliability, better fuel economy. All the above.
Good.
Yeah.
So, like all transportation, network communication needs some traffic rules. How would you like to deal with this on your commute? Uh, Kind of just a lot going on, but no one going anywhere. So, how does all that information get transferred on a single or two-wire network? Isn't there going to be a traffic jam of information going to and from the modules? Well,
Pocket.
a network, because of a protocol, allows a large amount of data to be moved in two directions. So, for example, if you're on cable, you may have one line coming into your house that provides television, it provides telephone, it provides internet, and of course, we can see this morning on internet we have two-way communication. I'm not just getting information; I'm sending out information. So all this is happening on one wire at the same time. And the reason why that's able to work is because there's rules within the protocol. So my physical structure for me is I have a coaxial cable that goes up to the telephone pole. That's my physical structure. How we convey information in that physical structure has to do with the protocols that the cable company is using that allows us to have a Zoom meeting, watch TV, make a phone call all at the same time, all on the same wire. And yet each system feels like we're the only one here. We're the only one using this information transfer technology because those rules are in place.
So
Sir
like
Brian,
TP.
Yes.
similar to our computer, sometimes it hangs or freezes. So what happens if that happens to this network?
So it could freeze for a couple of reasons. It could be that your computer froze itself. More commonly, what we see and we saw is that it's a bandwidth issue. In other words, the freeway is not big enough. So when we say you have small bandwidth, it's like instead of the 15 having 4 lanes, it's only got 2. So what's going to happen when you get to that 2-lane portion? And if it's in Rancho Bernardo, everything's going to come to a stop, even though it's technically moving through those 2 lanes. It doesn't feel like it when you're sitting behind those 2 lanes and the 4 lanes that are trying to get into 2. And that's the same that happens with our internet. So when we see
Create a bottleneck.
it bottlenecks, exactly. And that's why you see that freeze or you see that jerky speech. That's also why when that happens, if someone turns off their video and just talks, their speech is clear. But if they turn on their video and talk, you'll see everything kind of freezes and both their speech and their video is interfered because, again, we're trying to put all this through that bottleneck. And that's why you'll hear me sometimes say it's a bandwidth issue. And I get really frustrated with it because, most of us have the ability to buy more bandwidth. And if you're an educator or an administrator in education, I'm sorry, and you're doing these Zoom meetings multiple times a day, you kind of owe it to everybody else to spend the extra $40 a month and have enough bandwidth so we're not watching you freeze up. So I get kind of annoyed when I'm in meetings where, people that are paid to be in the meeting don't have good IT because I think it's really rude to everyone else being in the meeting. So, when we went online, I made sure that, I'm able to stream my both my video and audio along with a shared screen and everything all at once on top of anything my wife might be doing to make sure it doesn't interfere with our meeting.
So this type of network communication, is it like the TCP/IP protocol that computers use, or is it or different? Like
It's different, but it's probably similar because we're still talking about computers and everything's a 1 or a 0. So it's a different language, but it's probably similar just because we're going down to computer language of 1s and 0s.
Okay.
So, and I'll get there. I actually got some scope patterns. You can kind of see some of the different stuff that we see. So in general, the system employs a data bus. Data bus is our freeway. One or two wires to carry individual information packets, sensor outputs, computer commands, etc., throughout the network. So a packet. So what we're doing is we're not sending out individual words. We're sending a packet of information. So everything goes in the packet kind of gets sealed, and then that gets sent off to whoever we've addressed it to, or whoever's been told to get it and read it. And I can have multiple recipients, single recipient, and that changes some on network structure. It also changes. So for example, my driver's door module probably doesn't need to know that we are overheating. It probably doesn't need to know that, we're using the ABS or how fast we're going. There's a lot of things that module probably doesn't need to know going down the road. So we're not going to share that information with it. I just turn cruise control on. It doesn't need to know that. So it's not going to get that information. It's not going to be sent there. So the information packets are addressed. As we'll see, they're also given a priority, because certainly not every packet has the same priority. I mean, the fact that you'd like to put the window down has a lower priority than we just deployed the airbags. So, different messages have different priority codes, as we'll see. So we call this a multiplex system. Think of this bus as a freeway with on and off ramps to cities, i.e. modules, that can exchange information. So, just like any freeway, we have off ramps. In this case, I have a transmission module, a heating, ventilation, air conditioning module, and a dash module. And the cars are the information packets traveling on the bus. The information is only delivered to the correct destination.
Question.
Yes.
The LAN, you said one or two wire carrying too many information. So they have different frequencies or different PCM, how they carry many information in one wire.
Well, because they have a language that they communicate between zeros and ones in one wire.
Oh, binary operation.
Yeah.
Okay.
And so it's all binary, ones and zeros, and it has a priority code, and you're not allowed to talk when someone else is talking. And so there is this hierarchy that's set up in the software.
Okay, thank you, sir.
You bet. So this information, as we discussed, is carried in a packet of information, and it's all ones and zeros. So we have two different types of signals we learned about in electrical. We have analog signals, which is a waveform, like an AC waveform, or a voltage that just goes 0 to 5 and just can stop anywhere in between. And we have digital signals that are either low or high. Computers can only put out digital signals.
Yeah.
If an analog signal goes into a computer, it has to be converted from analog to digital for the computer to understand what that information is. So we need to look at that going in, and then the computer can output something digitally. So whether that's controlling an actuator, turning something on and off, or whether it's sending information. So the information on a network is carried in which of the following ways?
It's in packet of information.
It is packet information, and it's digital, so it's number 4.
Number 4.
Number 4, it's a digital language, and the information is in a packet. So number 4 is correct. So here is a simple network. There's different network designs. This is a looped series network. So a series network is just like a series circuit. It goes one to the next, and goes along. And if I have a break anywhere in the network, nothing after that break can talk to the stuff before the break, because it's a series. So one of the ways that we did to add some redundancy is we looped the series. And Many loop series networks can talk either way. So they can talk from the cluster can talk to HVAC, and it can talk over here to my memory seat module. It can talk both ways. So if this wire breaks, it can talk to the memory seat module going this way. So it can still talk to everybody, even if this wire is broken, because this network is allowed to talk both ways. Now, there's other networks with the exact same structure that can only talk one way. So again, depending on the protocol, the exact same physical structure, depending on a wire breaking, will have two very different outcomes in how the network operates. And that comes down to the protocol. So that's what I'm saying. So we have the physical structure, which we're looking at right here, the loop series network. And then we have the protocol that says the rules that we're going to use in this loop series network. So when we're diagnosing network systems, it's really important to understand the physical layout of the network, but also understand the communication protocol that's being used. And that putting those two things together allows us to develop a diagnostic plan for the network. So here is a picture of a wiring diagram for a network. And at first it looks very, very confusing. So I have quite a few modules here, some more modules over here. I have my diagnostic link connector and pin 2, which happens to be what I use to talk on this protocol. And so I'm going to highlight pin 2 here in blue, and it comes over here to this junction. And from here, I have a loop that goes from in purple from here to here to here to here and back down. It'll come all the way back down to here. So that would be what's called a looped network. So that is one loop of this network. When we connect modules like this, we call this daisy chaining. So it's daisy chain because it goes from here, then it goes to here, then it goes to here. Now on this particular protocol, this is a single wire network. In order to put redundancy into this network in case of a failure, this network is allowed to talk in both directions. So therefore, if I have a broken wire right here, I would get a code potentially saying we have a problem, but everyone's still going to be able to do their work and everyone's going to be able to talk. But it's letting me know, hey, you've lost some of your redundancy. One more break and things aren't going to work. If I look up here, this in yellow is a simple daisy chain network. So here, if this wire goes bad, we're not going to be able to talk to this module. If this wire goes bad right here, we wouldn't be able to talk to either of these because there's no redundancy on this part of the network. If I look down here, I have another daisy chain section I just highlighted in green, and it comes down to here, up to here, up to here, and up to here. So if this wire broke right here, I wouldn't be able to talk to these two, but I could talk to this one and this one. So a lot of diagnosis on a network is using a tool to talk to the modules on the network, our scan tool, and then seeing who can I talk to and who can't I talk to, and compare that to how my network's built. And based on that, many times I can figure out where the problem in the network has to be.
The loop doesn't have only single wire. Why it is called the single wire loop network connection?
Because all this communication only happens on one wire. So the signal here and the signal here are the exact same signal. They're just looping and going through. So this is a one wire network or single wire network. We see we only have one wire here in blue going out where my scan tool would connect. So all communication is only happening on one wire.
Okay.
And the signal in the entire network, even though I'm highlighting different places, should be the exact same everywhere. So if I put my scope on anywhere, I should see the exact same messages. It should be identical everywhere in the single wire network. So here I can highlight this in red. I can do another loop and we can see here, this is a looped series. So we have some straight series. This is strictly series. The green is strictly series. And then my purple, my red we just saw there are both looped series, which gives us some redundancy. And here I'll go through and highlight this in red. and I have another what? Looped series, part of the network. So parts of the network are looped, part of them are just a straight series. So this is still a single wire network. So this is using a wiring diagram and a highlighter to try to figure out who's connected to who, how the messages get sent, and then compare what I've learned here with which modules I might not be able to talk to or which codes I have in different modules. Some scan tools, factory scan tools, actually give me what we call network topography. And this gives me a picture of, this is not a wiring schematic, but this shows me the different networks that I have and how many I have and which modules are connected to each network. So I have my scan tool, and my scan tool is basically a module. And when I plug it in, it's going to talk to this module right here. And it's only going to talk to this module right here. So this module is actually called a gateway module. It's the module that is the gateway between one network and another network. In this case, between my scan tool and the two networks on the car. So I have a network right here in black, which has my ABS, my transmission control module, my brake module, and my powertrain control module. I have another module right here, the SCM, and I apologize, I don't remember the acronym right off. But it is also a gateway module. So it is able to talk both in the black network and in the blue network. It understands both languages, so it can share information. Just like this module can share information between both networks and share information between both networks and this network here in purple, which is my scan tool. Then I have this blue network, which is a slower speed network, where I have these other things on here. In this case, I have one module in red that's the passenger door module that is supposed to be there, but I can't talk to it. So it's telling me, you got a problem. He's supposed to be here, and I can't talk to him. These modules in gray are not supposed to be here. That's why they're grayed out. So these are optional modules that were not on this vehicle when it left the factory. And because I'm using a factory scan tool, we put the vehicle identification number in it, and then it knows what's supposed to be there and what isn't. The little lightning bolts here tell me these modules have new software available for them. So their software is outdated, kind of like when you're watching your TV or watching your Blu-ray player and you get a notice that there's a firmware update. So these things, basically, this little lightning bolt's telling me that these modules have a firmware update or a software update for how they operate.
This is an image you've taken directly from the scan tool, a factory scan
Yes.
tool? Oh,
Yeah,
cool.
this is taken directly from the factory scan tool. The Y-Tech is the name of Chrysler scan tool, and it's a laptop-based program that uses a vehicle interface cable. And so this is straight from a screen capture off of Chrysler's factory scan tool.
That's cool. Pictures. I like pictures.
So do
better
I.
with pictures.
I like pictures, and I like pictures of things that are in the industry today, not that were take me back in the Wayback Machine 20 or 30 years. So that's why for networking, I built my own presentation, is because it really kind of shows some of the stuff we're doing today. And we can see, here's our radio module. I don't know all these acronyms off the top of my head. Here's an amp. This is the sunroof module right here. So you can see there's, quite a few different modules here, but more and more manufacturers are starting to give us topography on the scan tool, which is really cool. But I like it because it helps explain how I can have three networks. All three networks are shown. One is a dedicated diagnostic network. Here's my high speed network. Here's my low speed network, which talks to most of the stuff that's on my body, but yet there's information I want to share between the two. So I need a couple modules that are able to speak both languages, and we call those a gateway module.
A lot.
Yeah. So a vehicle may have more than one network system. Is that true or false?
True.
True. After that last slide, I better get a lot of truths here.
Okay.
Another name for the network structure is which of the following terms?
Schematic or topography? Wait,
Topography is what I was looking for.
topography.
Topography.
Yeah. Yeah, topography deals straight with structure. I can figure out structure from the wiring schematic, but the structure and topography are used synonymously with each other. So that's what I was looking for there. So on that note, I got a case study coming up, and we only got 3 minutes left. So I'm going to start off the class with this case study. And this is a 2005 Avalanche with an intermittent no start and accessories don't work. And the customer brought the car in the day before. We scanned it for codes. It had some codes in it for some loss of power codes in the network. It had a couple network codes and some loss of communication. Cleared the codes. None of the codes came back. Customer didn't want to leave the car. The next day, the car got towed in. And when I hooked the scan tool up that I could talk to the car previously, I got this message: no communication with vehicle. Check diagnostic connector. Check ignition off. So now the car doesn't start. A lot of my accessories don't work, and I can no longer talk to it with my diagnostic equipment. So tomorrow we're going to walk through diagnosing this vehicle. And what I can tell you is everyone here already has the tools in their toolbox to diagnose it. You've already learned what you need to learn in this class to do it. You haven't learned how to use the tools yet. So this is really about walking through how we use the tools I've taught you so far in this class to how we would diagnose something that seems really intimidating, because I have a car that doesn't start and I can't use my factory tool to talk to it to help me. And so I'm going to walk you through the process. So we'll spend some time on this because it's a neat case study. I think the repair on it's really neat, and it's a good discussion. And that's why I use this case study in the class. So we'll do this to start tomorrow. And on that note, everybody, have a great rest of your day.